All right, well, good afternoon, everyone, and thank you for joining us. My name is Chris Vonamy. I am the Deputy Director for the DuPage County Stormwater Management Department, and we are here for a water quality outreach webinar called Flywheel Ecology, where we will learn how to build healthy, resilient ecosystems without dependence on herbicide, utilizing a three-dimensional integrated pest management framework for natural areas vegetation management. This is a free webinar, and one professional development hour will be made available for your participation. We have several of these workshops throughout the year. We find that these workshops are a great way to connect like-minded individuals and organizations who are concerned about the water quality in our lakes, rivers, and streams. These workshops are part of our public outreach and education programs and help us meet requirements outlined in our ILR 40 permit with the Illinois Environmental Protection Agency. The webinar is being recorded, so if you know of others who couldn't be with us this afternoon and might benefit from this information, we will provide a link to the recorded presentation shortly following the webinar. Thank you to Mary Beth Falsey. She is our water quality supervisor. She set up the webinar and was able to line up our speaker for today's program. And speaking of our speaker, thank you to Nick Fuller from Natural Communities, who will teach us how to build resilient and healthy ecosystems through Flywheel Ecology. And once again, I'd like to thank all of you for joining us here this afternoon. Excuse me, just a couple other quick remarks and reminders. This spring is finally here. Spring usually brings us warmer weather and a lot of rain. And sometimes that rain comes in the form of severe weather, including tornadoes. So be prepared and have a plan in place during this severe weather. And that reminds me, I have a quick question for the group. Why should you avoid tornado chasers? That's correct. They're always passing wind. Next week marks the 10th anniversary of our April 2013 event, where portions of the county received about 7.5 inches of rain that caused significant flooding damages throughout the county. So in order to try to avoid some of those potential damages, let's make sure that our sump pumps and battery backups are working properly. Downspouts are directed away from our foundations, hopefully not right at our neighbor's foundation, but hopefully away from ours. And that our drainage swales and storm sewer inlets are cleared of debris so that we can try to minimize or eliminate damages to our homes and properties during these spring rain events. All right, before I turn things over to Nick, I do want to remind everyone that you're muted. If you do have comments or questions during the presentation, please type those directly into the chat box and we will relay those on to Nick at the end of his presentation. Now, let me tell you a few things about our speaker, Nick Fuller. Nick has an unconventional vantage point of restoration ecology. This is due to his serving previously in the ecological restoration contracting world, serving as an ecological project manager at a land management agency, and now portraying a small business owner at Natural Communities. He enjoys toiling away on mind-numbingly in-depth plans for landscape-scale restoration projects. He also enjoys challenging conventions, always believing it can be done better and attempting to outdo himself at every chance he gets. Nick grew up near a forest preserve, which he explored often. This, unfortunately, fed his nature addiction at a young age, which continues to afflict him to this day. Sounds like Nick may need some therapy. But I think the only therapy we need is to learn more about flywheel ecology. So let's turn things over to Nick and get started.
Thank you. All right, so like Chris had said, my name is Nick Fuller and I am the Chief Ecological Officer at Natural Communities. And we are a native plant, seed, shrub, and tree nursery. And my role at Natural Communities is to coach folks on how to best use those native plants in their natural areas restoration projects. So today we are going to go over some of those tactics, really the strategy of that today. So I've been working in the ecological restoration industry for some time now, and honestly, I love it. And I'm sure a lot of people in this room or in this presentation love it as well. Working outside, always getting to do something different every day, always a different challenge, and you get to restore nature at the same time. But I'm pretty certain nobody really got into the ecological restoration industry to be applying herbicides. You got into the ecological restoration industry to frolic with the mythical creatures, to flutter with the flutterflies, and to buzz with the bees. But if your path was like mine, you quickly found out that herbicide application was a major portion of your role. And that may not jive with your tree hugger sensibilities. But today we are here to improve and we're looking to do better. Am I right? All right, so today I'm going to teach you my 4-step framework called Flywheel Ecology. Today we're going to focus on the strategy of Flywheel Ecology. You likely will recognize many of the tactics in the presentation, but you may not have seen them strung together in a comprehensive strategy like this before. So these individual tactics may not be revolutionary in and of themselves, but the revolution comes from the systematic way that you go about using this framework. That once you grasp flywheel ecology and its mindset, that your goals will come into significantly more clear focus, that you can see beyond one-off tactics, that you can see clearly years into the future, even decades. So let's go on the other side of the fence where the grass is truly greener. So let's take a look at these two trajectories of standard ecological restoration. So in red, we have the standard ecological restoration practice versus flywheel ecology in green. And on the x-axis here, we have time since restoration. And on the y-axis, we have ecosystem resilience. So you can go the standard ecological restoration route of incremental gains. And the problem with this route is that you have not built up enough momentum in your natural areas. And when you step away, say for a year or 2 years, your invasive species reseed and populations explode. And then you're forced to come in with a heavy hand due to the large invasive species patches, and you're forced to herbicide. And we're talking about Reed canary, Phragmites, honeysuckle, whatever the invasive species is. We've all seen them in detention basins, whatever those are, they take advantage of the vacuum that you just had created by herbiciding them, and then they explode once again. And you have this boom and bust cycle. And you feel like you just can't keep up, and you feel like you can't win, like you're on this never-ending treadmill, and you feel deflated as well. This is versus flywheel ecology, where you are actually investing into your future. And many people see this investing as a frivolous waste of money, but I can assure you that flywheel ecology is supremely beneficial. It's cheaper in the long run, and it will save you substantial amounts of time and herbicide over a given square foot. So you do need to recognize that there are some upfront sacrifices to flywheel ecology, but those sacrifices are in time will turn into exponential growth. Also recognize that you will have doubts up front. Is this working? And you'll become impatient, but time and patience are necessary and key to this exponential growth. You might even say, Nick, I can't afford to do this, but I would say that you can't afford to not do flywheel ecology. So I want you to think of this in another way. So let's flip that chart upside down. So I changed the y-axis here to required maintenance in effort and time. The x-axis is the same. So you can see the flywheel ecology will take more effort up front, but in a few short years, you will have way less effort that's necessary to keep your ecosystem healthy. So think of this extra time as your profit. And now the real question is, what are you going to do with that extra time? And I know what y'all are thinking, but we still have work to do. So how did we get to flywheel ecology? Well, I've spent nearly 2 decades in ecological restoration, from woods to wetlands to prairies and rivers. And with all of these projects, I've had some great successes working on threatened and endangered species, rare and remnant ecosystems, miles upon miles of river and stream restorations, some seriously challenging stuff and challenging sites as well. And on these projects, I was able to spend long durations of time maintaining these projects to see their trajectory. Trajectory not just over, say, a 3 to 5 year period, but over a decade, sometimes even 15 years. And I can tell you which approach fared significantly better. And along the way, I've learned a lot from some of the giants in the industry. So first, I worked for a well-respected ecological contractor and pioneer in the industry, learning the foundation of ecological restoration for vegetation management. And second, at the land management agency, I had the opportunity to manage large tracts of land for very long periods of time. And there I had the pleasure with working with ecologist Scott Coble, plant ecologist Scott Coble, who taught me the power of land use history using the 1939 aerial and database trajectory of our natural areas in the Chicago area. Scott Coble, who in turn learned from his predecessor, Wayne Lampa, another well-respected botanist in the Chicago area. I learned a ton of landscape restoration techniques from Herman Jensen, a restoration ecologist giant in his own right. Eric Knighty, who is a great stream restoration habitat design person. And I've had the opportunity to pick the brains of some of the most well-respected land managers in the Midwest, stealing, and I mean borrowing their best tips and tricks as well. So I'm talking about forest preserve land managers, federal land managers, land trusts, some of the elites in the industry. And there I have also had the pleasure of working with and project managing some of the best, most of the ecological contractors in the Midwest. And across the board, I've learned all of their best of the best secrets for natural areas restoration. And I want to give a shout out to Ryan Anderson from the Integrated Pest Management Institute of North America, because he has helped me push my limits of where integrated pest management can go for natural areas. So now these land management agencies that I worked for, they had some pretty sizable chunks of land, but we all know that restoration is severely underfunded. So we need it to be better, we need it to be more efficient, and we need it to be more strategic. So I had to figure out ways to do that. So in addition to ecological giants, I also looked at outsider knowledge for some basic principles that they had that the restoration industry has not yet developed. So principles in industries that have significantly longer track records than ecological restoration. So I've researched efficiency and effective principles, systems principles, some of them really excruciatingly boring, I can tell you, but don't worry, I read them, you don't have to, but I do have a few books that I like here. So I've got Good to Great by Jim Collins, which is actually where the flywheel principle comes from. I've got the 4-Hour Work Week here. That one's obviously very popular as well by Tim Ferriss. So the takeaway from this is don't do more, do less. By doing less lets you focus on the importance. Books like Work the System by Sam Carpenter teaches you how to develop systems and stick with those systems. And books like Mike Michalowicz's book, Clockwork, which helps you get those systems automated. And when you develop a focus and you distill it down to the essential principles of that focus, and you develop a great system around that focus, and then you work that system to give it momentum, you've hit a world of magic, and that is our goal today. The person who grasps principles can successfully select their own methods. The person who tries methods ignoring principles is sure to have trouble. Ralph Waldo Emerson. So I love this quote. Here's another quote. Strategy without tactics is the slowest route to victory. Tactics without strategy is the noise before defeat. Sun Tzu. So I love this quote too. And these two quotes inextricably tie together strategy and tactics. You need both. But you need to develop first your strategy and then execute day-to-day tactics to meet the long-term strategy. So flywheel ecology is the strategy that we're talking about. So tactics, on the other hand, are the individual steps or the immediate actions that we do on a day-to-day basis to get you to your ultimate strategy. So for example, you could be really great at controlling honeysuckle. This is a tactic. But if you can't keep the honeysuckle at bay after it's been cut, what has that individual tactic gotten you? Furthermore, if you don't end up with a healthier system and a more resilient ecosystem after you've just sprayed a bunch of herbicide on the ground, what has that gotten you? Are you really better off, or did you just waste time resources, and put a bunch of herbicide on the ground for no reason. You need a strategy to look beyond initial control tactics to build your resilient ecosystem. So as opposed to tactics, the strategy is the fundamental truth that serves as a foundation for a system or a chain of reasoning. So we're going to interchangeably use principle and strategy terms today for today's presentation, just to let you know. So I would say that many approach restoration as a series of tactics or methods, but they don't stitch those tactics together as a strategy. So if you lean heavily on tactics, you will miss the forest for the trees. So let's dive deeper into tactics versus strategy for restoration. So tactics are, how do we kill, say, reed canary grass? We use X product at X rate, and you will get X kill rate. Versus strategy, why are we doing these tactics? What is our ultimate goal? We are killing reed canary grass because we're going to be implementing a multi-year strategy that, through the use of very specific suite of native plants and seed planted in very specific locations with very specific purpose and time, and then maintain those areas with a very well-oiled and very disciplined management regimen in concert with evaluations, so that we can take that data that we're evaluating and plug it back in to the following season. So what is the Flywheel Ecology strategy? So when I first started ecological restoration, I learned invasive species. It seems really intuitive. I think a lot of people in the industry learn it this way as well. But once you learn those, everybody knows that you can't unsee invasive species. You see them everywhere. You see them driving down the roadside. You go on a hike, you see them there as well. And because of this conditioning, my mind always went to controlling invasive species first. It's this pest first mindset. And this seems to be the case across the industry as well. And if you like sports, think of an analogy. So a lot of practitioners may have a great tactical a tactical defense game, but they have they're lacking their offensive strategy. So there is no linking of multiple tactics together to achieve the long-term strategy. Integrated pest management is a tactic or a series of tactics. They're good tactics, but they are just that. Flywheel ecology, on the other hand, is a fundamental principle, or it is a long-term strategy. Flywheel ecology is most benefits, not least impacts. Flywheel ecology thoughts and actions are driven by building resilient ecosystems, not just by killing pests. Flywheel ecology is three-dimensional in its approach, and it's holistic in terms of building resilient ecosystems. Flywheel ecology is a discipline not unlike the martial arts, in that it is a lifelong pursuit of continual self-improvement and site improvement. So hopefully you can see the difference here. And I think when you do shift your mind to seeing the difference, going from least impacts to most benefits, you'll approach the world with a whole new lens. So speaking of principles, who here has heard of Vilfredo Pareto? So he made several important contributions to economics, and one of them that he made was the Pareto principle, also known as the 80-20 rule. So Pareto noticed that in Italy, 20% of the population had 80% of its wealth. Pareto also noticed that the same ratio applied to many, many subjects across the board. One time he noticed that 20% of his pea plants were actually producing 80% of the peas. And this is the example that caught my ear because it has to do with plants, obviously. So if you're wanting to maximize productivity, you want to focus on that 20% of the techniques that are producing 80% of the results. So to be able to provide focus, you need to first drop the unproductive 80% of your efforts. And if you stop doing the unproductive 80% of your work, and then continually use that freed up time to put that back into the 20% productive portion of your work, your gains will be unstoppable. So finally, my 4-step strategy called Flywheel Ecology. We have planning, planting, maintenance, and evaluation. And you're probably saying, wait a gosh darn minute here, Nick, I know what this is. This is integrated pest management, and it largely is. So sorry about that, but so this part is integrated pest management, but I will get you light years beyond integrated pest management later in the presentation. Okay, so let's start with the foundation here, and that is the planning and the planting stage. So in this step, we're going to try to understand the current state of your particular natural area, and then we're going to plan to build a foundation moving forward with your restoration in a planned way. So first thing we need to do is identify the communities that you have at this moment in time, the current natural communities. So this is a very broad brush look at the site to group like areas together or like issues so that we can make a plan for the next step. So this is a project that I've worked on recently. It's actually in DuPage County, and we're going to use this as an example. So what do we have here? So the first question is, do we have any existing natural areas? And we do. We actually have multiple types of natural areas in here, and I'll get into those different types. So do we have any remnant areas? So if you do have remnant areas, they're the first and foremost that you want to protect. So you might ask yourself, what is a remnant? So think of a remnant as an ancient, thousands of year old ecosystem that contains vast riches of ecological wisdom and resources that have accumulated over time. So some might call these old growth forests, but in the Midwest, we also have old growth prairies and old growth wetlands in addition to old growth forests. These areas have substantial old growth characteristic in them, otherwise known as remnant. So here in this particular project, we do have old growth remnant woods. Those are indicated in green on here. So they have a lot of oak overstory. They have a pretty decent native wildflower and grass herbaceous layer in there as well, but they're greatly suppressed due to invasive species. Again, this is a great ecological resource, and we want to preserve these first and foremost. So do we have any other native areas here? We do. We actually, in yellow, have a native planting here. It's a prairie recreation, so we're going to want to save that as well. Do we have any other natural areas communities in here? We do. We have the red area here, and it's a post-settlement community is what we call it. And the type of post-settlement community that we're going to call that is a second growth woodland. So what is a post-settlement community? So this is a community that's developed post-European settlement. And a lot of times these communities are actually less than 50 years old. So it has not yet had that time to develop into an ecological masterpiece. So on the natural areas spectrum, these have significantly less natural resource value than, say, a remnant old growth, say, oak woodland, or even potentially and very likely a prairie recreation or any sort of recreation. So that's our area in red here. It's basically a mishmash of invasive woody species and native weedy trees and shrubs as well. This does not appear to be a remnant because it doesn't have an oak overstory and it does not have a decent native understory. So another thing that we have here is the area in brown. I'm going to call this a blank slate because it was a farm field recently taken out of production. Oftentimes, you may also have areas that are monocultures of invasive herbaceous weeds. We are fortunate on this project that we did not have that, but if you do have Phragmites, reed canary grass, whatever, you're going to want to recognize those and then make a plan to address those before you get into the planting stage. How do I know if it's remnant, recreated, or lacking remnants and land use history? So that is what we have here is the 1939 aerial, and I call them the magic 1939 aerial. And it's magical because it is like a time machine traveling back in time to allow us to look at land use history. So first, what I see here are dark gray splotchy areas, and dark gray splotchy areas are good. They are usually remnant oak woodlands. And since these were here in 1939, they typically are remnant because we largely would have not had the second growth woodlands here yet. Second, what I see here is a patch of agricultural fields indicated by lighter gray, typically squared off unnatural lines. That's kind of the two things that I'm seeing here. So where is our particular site? It's right there. So let's zoom in a little bit more. So now let's take a look at the woodlands here. So if you look at the left-hand side of your screen and you see a difference in here. So if you look at that woodland, it is very open oak savanna. You can actually pick out individual trees and imagine how much light was streaming down to the ground in these areas. versus the denser oak woodland to the bottom of the screen along the stream there. So even in the densest oak woodlands in 1939, they're still really open, and you can actually pick out light where you can actually see the woodland floor through the canopy. So there's still quite a bit of light going through there. So now let's compare that to today. So this is a side-by-side comparison of the two. So do you notice anything different about the density of the historic aerial versus the current day on the left-hand side? So it looks like we have a really dank, dark forest today, and we do. And the reason why is that it's due to oftentimes a lack of fire historically, and a couple other things we'll get into here in a minute. And that the invasive shrubs and the overstocked native trees are choking out the oak woodland and its ecosystem to death. And so it's really a big problem. So why did so many trees grow in between 1939 and today? Well, again, in historically, back in the 1800s, Native Americans were setting fire to keep their landscape open. They were kicked off of their land. Once Europeans came in, they largely were grazing these woodlands, which kept them open because it was kind of keeping in check all of the shrubbery. But once the meat industry collapsed in about 1940 or so in the Chicago area, they pulled the cattle off of the woodlots, and then the woody species they basically were released, and then they started growing exponentially. These trees created great amounts of shade in our savanna and our oak woodlands, shading out the entire woodland flora and the grasses. So this woody growth, it's native and it's non-native, and it's our largest threat to our oak ecosystems in the Chicago area and honestly the entire Midwest. And because now no light is getting down to the woodland floor, we're losing our wildflowers and our grasses. And honestly, the oaks cannot develop into adults as well. So we're losing our keystone species in there as well. So we're not going to get into this too much today, but also know that soil maps hold secrets as well. So if you look at the different soil types, if you're looking to create, say in our farm field, you're trying to develop what these communities should be, soil maps can actually provide secrets to them. So you can look and see, are there hydric soils? Well, those probably would have been historically wetlands. Are there woodland soils? Are there prairie soils? And that gives you clues as well. And then you can map out what your prairies or whatever the community is in your area. So now that we know our pre-settlement communities, we now know our current state of our remnant communities. We now need to know the current state of any modern day communities, for example, the ag field, the second growth woodlands, the prairie recreations, etc. We need to identify the threats in those communities and then mitigate for those threats. So if you're in the Midwest, a handy guide to identifying threats and really just a treasure trove of knowledge is the Chicago Wilderness Biodiversity Recovery Plan. So if you see the link at the bottom of the page here, you can actually get this as a free publication. And it identifies nearly all the plant communities in the Chicago area, really even in the Midwest, and it outlines the most common threat types specific to each community. So this is an excellent launching point for those who may need some help identifying communities and their threats. These threats usually will line up with the community type. So here are a few threats on this site. So we have the oak woodland. So again, that's in green. So we're going to identify the threat here. So invasive species, honeysuckle. But we also have overstocked native trees like wild black cherry. Basically, don't have enough light hitting the woodland floor to sustain this ancient ecosystem. So the mitigating action here is we're going to mow or we're going to clear those invasive species out. So in our second growth forest here, we're going to remove invasive species again. We're going to remove overstocked native trees to create a more natural fire-dependent oak woodland community. So both of these communities have a threat of lack of light levels to sustain a native herbaceous layer. And if you don't have a native herbaceous layer, you can't sustain a controlled burn. So then that's critical to get it in there. So in our agricultural field, the threats here could be agricultural drain tiles artificially changing the hydrology of the site. So you might want to break drain tiles to restore natural hydrology. We have erosion in the swales. Another threat is we have no native plant community to speak of at all. So we're going to want to augment that obviously with natives. So the largest overriding threat to our natural communities, like I had mentioned, is the lack of fire. So always have the mindset of designing these natural communities to be burnable, where if you can't get them to have a controlled burn, you really have an issue on your hands. So when you're designing them, design them to have the enough light in the system to sustain an herbaceous layer that will carry fire. And if you don't, you're likely to have a failure if your project is of any scale. You just won't be able to maintain it. So as I had said before, many times in the Chicago area, we're looking at a ground up ecosystem recreation, and you may have a remnant community that coax back to life, but planting or augmenting is a powerful tool in both instances. That's what we're going to be talking about now. So first, you have to know your community. So we're going to talk about soil moisture first. So dry is on the left-hand side of the screen here. Dry, like myself, most people overestimate dry is what I find. Moving towards the middle of the screen where I've got turf grass here, pretty much if you can grow turf grass on it, you're somewhere in that mesic or normal soil. So you got drier on one end of the spectrum, but you have wetter on the other. And then we have wet prairie grading down into the cattails, which is emergent on here as well. So you have to pair that with your light regime. So, and I find that most folks, again, in this case, including myself, overestimate the amount of light that any area is receiving. So full sun, as a reminder, is 6+ full hours of sun. Think of a wide open treeless prairie. Part sun, 4 to 6 hours of full sun. And then think of that really wide open savanna in there in that 1939 area. We're talking 50 to 75% open canopy. Shade is dappled light all day, possibly even some full sun, maybe an hour or two of full sun. Think of that denser woodland in the 1939 area along the stream. This probably has even 10 to 20% open canopy in there as well. Deep shade is anything darker than that. Not much in the Chicago area was any darker than dappled light. And in most cases, it was substantially more light. And usually in our restorations, more light is better. So now let's take that soil moisture and the light moisture regime, put those two together, and let's go back to the example. So in our ag field, we have the area in blue at the bottom of the screen here. So that's full sun, wet soils. This is a sedge meadow grading into a possibly emergent wetland, and we are going to use live seed, and we're going to use plugs in here. So in our yellow area, we have full sun, normal soil moisture. So we have a mesic short grass prairie. We're probably going to use seed in here to achieve that. In our light green areas, we have full sun, slightly wet soils. We have wet mesic swales. So in here, we're going to use seed and plugs to take care of that area. In our oak woodlands, the area in green, we have enough remnant herbaceous material, and we have a relatively healthy oak overstory. And this probably could recover on its own with management, but we're going to give it a little bit of boost. We'll think about throwing some woodland grasses in here just to cover the ground. So in the area in red, this is our second growth woodland again. So we've dramatically improved our light situation in there by removing the woody invasive species and removing our overstocked native trees. And the reason why we need to do this is we want to grow native wildflowers and native grasses in there. We also probably want to establish an oak canopy in here. So you might want to consider planting oak trees, native shrubs, and we would want to obviously use a native woodland seed mix in here. So this is mesic shade. So now that you've identified the general communities of where you'd like to see these areas move towards, now we need to get a little bit more into the weeds and come up with a specific species list for each plant community that best fits the site. The best way to do that is to reference the remnant ecosystems for inspiration, because they are the most resilient, and there's a reason why they co-evolved with each other over thousands and thousands of years. They are ecological masterpieces. So botanists studying remnant ecosystems noticed a general pattern that if you look at the geologies, the moisture, the soils, et cetera, across the landscape, that these plant communities create a pattern. And if a community in this geographic spot has the same traits mentioned as another geographic spot, then they will also likely have the same plant communities here, at least remnant plant communities to speak of. These plants tend to associate together in these plant communities, and those are called plant associates. So the king of plant associates in the Chicago area is called the flora of the Chicago region. Nobody would ever call this a light field book, but this is an awesome resource here in the Chicago area. And honestly, again, it applies to the Midwest a whole largely. So this will give you community-specific plant associates. For example, white oak, mesic woods in the Kettle Moraine, underlying geology. The plant associates there would be oak sedge, shooting star, side flowering, aster, etc. So this is how restoration ecologists develop species lists for restoration projects that are site-specific, community-specific, light and moisture-specific. And this is how you sow the seeds for a resilient ecosystem. So if you listen to the land, it will give you what you need. So even though this step is really important, I would say it is probably overly detailed for most, and particularly for smaller scale restoration projects. But if you are doing a large scale restoration project, or you're dealing with a remnant community, you deserve to give it this detail in the planning stage, because again, this is building our foundation. So it is a bit complicated and potentially overcomplicated. I just wanted to present this material to you so that you had an understanding and an appreciation for how restoration ecologists develop species lists. So don't worry, there are cliff notes that you can use. Just use a predetermined native seed mix for this, and it should be fine as well. Just make sure you have an ecologist look at it to make sure it is appropriate to your specific site. Okay, so the seed mix is the backbone of your effort, and they will provide the basic diversity, largely the diversity in your site, and it's the primary way to get native coverage across your site. So now you want to pair that native seed mix with live native plants, because it's a great way to supplement in a few critical ways. Number one, it could be diversity. Number two, we'll get into in a little bit later, but basically resilience. So one example of using native plugs would be wetlands and flooded areas. So if you throw seed in there, it may wash away. So you may be obligated to use plants, or you might want to use certain sedges or certain plants to dovetail with your seed mix to build resilience in there. So a lot of seed that's commercially available may not have all of the species that you need to create a resilient ecosystem. And so we would pair the seed mix with what we call warrior plants in the industry. So number one, get the right seed mix in place for both communities and species. Number two, deploy plants strategically. They are great, but they can get expensive. So you want to use them properly to augment the seed mix. You don't just willy-nilly throw them in there. So plants can be, again, used to augment diversity. Today, we are going to focus on planting warrior plants for resilience to help reduce your herbicide and to reduce the time and maintenance that you spend on it. So warrior plants are typically strongly rhizomatous plants. So in other words, they spread aggressively through their roots to hold the ground against invasive species. We don't have time today to get into this too much, but just to let you know, we do have a relatively comprehensive list of warrior plants for various communities on our website. So the deployment of these species can get quite expensive again. So you want to use a restoration ecologist to help guide them into the areas that they're going to provide value. So remember, this is the 80-20 rule we had talked about before. So deploy them only where they're needed to meet specific requirements, either to stabilize the site from erosion or to stabilize the site in terms of disturbance. So deploy them only when needed. Usually after an herbicide treatment is perfect to fill in those dead patches. Once you have the correct seed mix and you have the correct plants in the correct location to build momentum, now you need to maintain your masterpiece. So obviously there's tons of information on maintenance. We could give 3 presentations on just maintenance. So we're just going to cover the basics today. So I see fire and mowing as the 2 most important management tools that you have to keep your natural areas looking good. So mowing builds initial management in your flywheel. Mowing is used to establish native plants in the early years. It's critical. It controls weedy species to allow your native seed to germinate and then develop into mature native plants. Years 2 and 3, you will likely be spot mowing to control weeds. Hopefully in year 3, you may have enough native species in there to support a fire. And fire builds upon that initial momentum that you just created. Fire encourages fire positive species and fire dependent ecosystems like most of the native ones we have here in the Midwest. Fire helps control invasive woody species. Fire helps remove the duff from the previous year, which allows you to focus your herbicide treatments to be more targeted and to be more effective, allowing you to reduce herbicide application. I have to briefly touch on native plant augmentation at this point in the presentation, and I see planting and seeding as a very powerful tool in terms of maintenance. So likely the most important tool, and we'll get into that a little bit later in the presentation. I also have to touch here on woody invasive species control. You likely know that fire is your best tool at keeping woody invasive species in check. But what if you can't get in a good burn this year? What if you can't get in a good burn for a few years? Or what if you finally get in a good burn and some of the honeysuckle or whatever the invasive species is was not fully controlled? It was either too large for the fire to control, or maybe a spot was too wet, it didn't burn well, you lacked fuels in certain areas. And again, this is okay, it will happen to everybody. And know that it's going to happen and have a plan in place. So with Flywheel Ecology, again, we're going to think of that 80-20 rule. So what we want to do is let the fire do its work on a vast majority of the woody invasive species first. Then only after a fire has gone through, we're going to evaluate it. Either in the spring or in the fall, we wait until the invasive species are green and the natives are dormant. And this will show us what stragglers are still left over after the fire that were not top killed. Again, that's that 80-20 rule. So if we let the fire focus our efforts, our most expensive efforts are human resources. And so we want to use those with pinpoint accuracy where it is needed and only when it's needed. And that's going to save you substantial time and substantial money. So when besides that, it's significantly more cost effective, and you're going to use significantly less herbicide with this approach. So when we find these, what we do is we go in, we find the individuals that were not top killed, and then we use a brush saw to cut stump them. So this is the 1-2 punch, and it will significantly step up your woody invasive species game. So we have many more thoughts on woody invasive species control. We unfortunately don't have time to get into them today, but this is one of the basics that we use in terms of flywheel ecology. Okay, you have considered all other management ways. They didn't work for you, so you move on to herbicide. So that's usually the end of the integrated pest management journey. But that is not the end of our journey today. This is actually the beginning of our journey. And this is exactly where flywheel ecology comes into play. So anytime you use herbicide, you want to have a plan in place before the application to move away from it next go around. So a good way to change your mind around herbicide use is to think of it as not only killing invasive species, but also think of these herbicide applications as a creation of a native planting bed for putting in more native species. So always be ramping up your native competition and ramping down herbicide use. So on the right-hand side of the screen here, I call this an herbicide ramp. So we're going to start at the top of the herbicide ramp. So this is broadcast herbicide application. You only want to use this necessary usually, hopefully only once or maybe twice at the beginning of a project to create a site-wide planting bed. Number 2, we have spot herbicide application moving down the ramp. Then we move on to hand wicking, only treating individual plants. This is how we would like to see it progress several years into the project. So you are always going to miss invasive species. This is okay. Just make sure that those invasive species do not go to seed. So follow up each herbicide application by cutting, say if you're treating reed canary grass, by cutting the invasive species seed heads before they go to seed. A stitching time saves 9 or 99 or 9,000 999 reed canary grasses, you're going to save yourself a ton of time by preventing them from reproducing. So be militant in keeping your weeds from going to seed. This is critical. So herbicide with intention. So again, before you herbicide, do your herbicide application, you want to have a plan in place to fill in these gaps that you just created by herbiciding. So post herbicide application, put your focus into seeding and planting in those controlled areas to build that resiliency. So purchase them or have them collected or ready to go before you actually apply your herbicide. Remove that bottleneck so you can hit the ground running. Lack of preparation, discipline, and consistency in this will lead to you moving back up that herbicide ramp. And I've had it happen on my projects, bad ecologists, but I've learned my lessons, and these are the lessons. And so when you're devising your strategy, you want to have a short-term game and a long-term game in mind. So what is this short-term game? The Natural Communities has developed a native rye cover crop mix. It's Canada rye and Virginia rye. It's on our website. It's fantastic to patch these planting beds. It's cheap. It germinates quickly. It works in the vast majority of communities, wet, dry, partially shady, full sun. It works across the board. And this will not give you diversity. This will not give you long-term stability. Again, this is the 80-20 rule. This is what gets the job done in the cheapest way possible. This native rye cover crop is your mix. It's your sprinter species that they will cover the ground quickly. Sprinters run fast, but unfortunately they run out of steam fast as well. So simultaneous to getting your desirable sprinter species established, you want to have a long-term game as well. And your long-term game, these are your marathon runners. So these are your warrior plants. So you want to dabble these warrior plants in each and every year. This is where a lot of people think it might be a waste of time, but it's not. You want to do them each year, every herbicide application, consistently building this momentum over time. And you might think it is too expensive. How on earth would you afford that? But I can tell you it can be done for less than $100 per acre per year. I've seen it and we've used it, and it gets cheaper and cheaper each and every year. So each year you'll be saving time, and you can reinvest that time back into being more effective in terms of other maintenance, and it has the snowball effect. So while we're on herbicide, we need to take a look again at the 80-20 rule. So this time it is minimum effective dose. So minimum effective dose is the smallest dose that will produce the desired outcome. And this comes from the medical field in regards to dosing of medicine. So just like medicine, if used properly, herbicide can be an effective treatment in certain applications, but it is not in and of itself a solution. So when you talk about the correct herbicides, you have to have several considerations beyond just being effective. Correct herbicide means it's the best choice in terms of the environment and in terms of human health. The correct herbicide means it will not disrupt the native planting augmentation aspect of flywheel ecology. Certain herbicides have very long residuals, and they will not allow you to effectively augment with native species. So caution, don't use those. You want to use herbicide that will allow you to plant each year to build a resilient ecosystem. So you want to use, in addition to that, you want to use the least amount possible that is still effective. You don't want to use this medicine you want to use this medicine for the least amount of time possible. Medicine, just like herbicide, needs to be incorporated into a holistic medical approach, not used in a vacuum in and of itself. Think of it this way. If you eat foods that are unhealthy, how about if you just ate pizza constantly and you think that a medicine will solve your medical issues? You are incorrect. Your body needs nourishment and it needs exercise to be healthy. Ecosystems need nourishment in terms of native plants. Plants are the basis for ecosystems. Ecosystems also need exercise. Think of that like controlled burning and mowing to keep them in tip-top shape. Herbicide alone will not give you a healthy herbicide, just like medicine will not give you a healthy body. Herbicide is just a tool in the toolbox. It's a blunt instrument, and use it only when necessary. So where can you get some data for this minimum effective dose? If you are not aware of Chris Evans, you should check him out. His research is on invasive species. He is a forest extension and research specialist with the Dixon Springs Agricultural Center in Southern Illinois. And his research is based on invasive species treatments with herbicide. His research provides us with the data to narrow down which herbicide is effective and what dose is necessary to achieve minimum effective dose. Herbicide, again, is an important tactic. Remember, it is just that, as a tactic in our strategy in the full flywheel ecology principles. Make sure you run whatever herbicide you use through the full lens of minimum effective dose in the context of flywheel ecology. So now on to evaluation. Monitoring evaluation can be as detailed or as basic as you want. For our most basic needs in flywheel ecology, all you need to do is get out, walk in nature, and discover what worked and what did not. Don't overthink it. Where are these areas where we didn't establish natives? Why are they not establishing? Take notes so you can address them later. So I think you're starting to see the picture, but just to hammer it home, think of the 4 steps in the flywheel ecology framework. Picture a huge, heavy flywheel, a metal, massive disc mounted on an axle. And to get this thing moving, we need to get the entire team to push it. We all have to be pushing it in the same direction. We can't have one team member pulling and another team member pushing. Everybody has got to be aligned in pushing the flywheel in the same direction. Then you got to get the team ready and you say heave ho, and we push as hard as we can. And we get the flywheel to inch almost imperceptibly forward. So you have to keep pushing that flywheel and keep pushing it. And after much persistent effort, you get that flywheel to turn one complete turn. One turn is 1 year in natural areas management. One turn does not get you a resilient ecosystem. You have to keep pushing that flywheel over and over again, and it moves a bit faster. And with continued great effort, you get it to move around a second rotation. So what does this look like in practice? So you run the flywheel over and over and over again, the 4-step framework we talked about: plan, plant, maintain, evaluate. Year 1, 2, 3, 4, 5. So each flywheel spin, you distill what is working. Think of the 80-20 rule and reinvest it into that 20%. Control invasive species using minimum effective dose. Make sure that they don't produce seed. Plant native rye cover crops to get stuff growing quickly that's native, and then plant warrior plants, dabbling those throughout your site. Year after year, if you do this, I promise you will have less weeds, more natives, and a more resilient ecosystem. So the momentum of this thing eventually kicks in your favor, hurling this flywheel forward, turn after turn, its own heavy weight working for you. And then at some point, bam, you have breakthrough. Nature takes over, and now all you have to do is give the flywheel little nudges each year in terms of maintenance. So with flywheel ecology, you now know how to unleash Mother Nature's healing powers as well. So how do we put it all together in terms of flywheel ecology? Well, first comes the mindset change. This is critical. Remember, it's organizational. If you add in the flywheel and then you add in the 80-20 rule, give it a little bit of time and a little bit of love, and you sprinkle Mother Nature in there for some exponential growth. And when you stack this all together, its synergistic abilities are limitless. And this practice of flywheel ecology can be rewarding. Remember, it is a practice. I'm still practicing and learning myself, and it gets more rewarding each and every year. Also remember that flywheel ecology is a continual investment. It's a continual disciplined effort over time. Swooping in once every 1 or 3 years to do maintenance is not adequate. This does not build momentum. At the same time, flywheel ecology does not need to be expensive. Trickling maintenance over time in a strategic way is the best way to build up your flywheel momentum. So building a more resilient ecosystem year after year equals less herbicide use year after year after year. It will save you time and frustration. And we could take this time and frustration and put it into either restoring more natural areas or, say, converting turf grass, which again will save herbicide, and it has this dramatic snowball effect. So I'd like to finish here with an offer. So we only had time today to cover the strategy, not the tactics. So we would love to hear from you on your tactic questions that you may have. And we have several ways to do that. We might have a little bit of time here at the end to talk, but for natural communities, we have if you have a more complex dialogue that you want to ask us questions, we actually have a way to schedule a free Flywheel Ecology consultation on our website. Number two, we have, if you have more straightforward questions, we have a Q&A page called Ask an Ecologist where you can ask us as well. And number three, you can reach out to us with email. And so I hope that you take up Flywheel Ecology in your natural areas management, and I wish you luck on your journey.
Well, great. Thanks, Nick. A lot of great information there. We do have a couple questions here, and we got a couple minutes left. So why don't let me relay these on to you here real quick. First off, are there any local sites where Flywheel Ecology has been used that the public can visit?
That's a good question. A lot of the sites where I've used Flywheel Ecology are for private clients, and that is not the case. If you wanted to send me an email, I probably could point you towards a couple that you could check out. I apologize for my dog barking in the background. I think that's probably the best way, is maybe shoot me an email.
Okay. Very good. A couple other ones here. What % reduction in herbicide use can you obtain by implementing Flywheel Ecology?
So it really depends on what site you have, what invasive species you have, how long you've been doing this for. It runs the gamut. For example, in my yard, I've used zero herbicide, but I've done slightly different techniques. The techniques that I presented here for large scale land managers, and I'm running some experiments in my yard. We're going to see if we can do some grant applications where we can do some research with the Integrated Pest Management Institute of North America to kind of run some side-by-side tests to actually have some data to back this up. But there are techniques where you can get down to zero, particularly with woody management. I've had really great success with zero herbicides, at least on a relatively small footprint. I don't have hard data yet, so.
Okay. Well, very good. We'll look forward to some of those studies. And how about this? Would Flywheel Ecology work in much smaller restoration areas like backyards or rain gardens?
So I think so. So just like I had said, on my house, I use zero herbicide. One of the biggest techniques that I use in my yard is my yard was covered in honeysuckle. I used a chainsaw, cut down the big honeysuckle. It is going to resprout. We all know that. So when it resprouts, what I did was go back with the line trimmer, a very aggressive professional line trimmer, and then I weed whacked the resprouts down. But not only that, I brush cut around the collar of the honeysuckle or the buckthorn, and that simulates fire, and it actually creates significantly more damage than just cutting off the sprouts, for example. On top of that, I'm running the burn through after I've done that, and then I follow up the burn each and every year and cut the invasive species. And I'm almost certain that if we ran that test on a large scale, it actually would not take any more time to do it that way. And my guess is it would actually be the same effectiveness. Otherwise, hand pulling and then going back in and planting something in its place when you say pulled Canada thistle, making sure that you're collecting seed and putting it back in there. Yes, I do think it would work.
All right, very good. Well, I don't see, oh, one other question. Can you repeat the herbicide minimum effect dose source that you mentioned?
So his name is Chris Evans, and I'm pretty certain if you just look up Chris Evans and look up herbicide tests, he has many, many different types of tests. I just saw one recently on stilt grass, but I think he's got them on Japanese knotweed, on a vast majority of the woody species in our area. He's been doing this for decades, and I've seen him present multiple times, and it's usually fascinating. It is very specific to herbicide use. So again, I just want to caution everybody, that's just a tactic. You don't want to rely on that necessarily exclusively.
All right, great. I think that's all we have time for. I just want to point out one thing. I'm kind of proud of myself because I've been applying that 80-20 rule for when my wife asked me to clean the house. Anyway, that's not important right now. Nick, thank you very much. Great job on the presentation. Thanks for sharing your knowledge and experience with us. I also want to thank our audience for joining us this afternoon. We hope you have enjoyed and learned a few things from this webinar. Please remember, Mary Beth will be emailing everyone a link to the presentation, a recording of the webinar, and that ever so important PDH certificate. Our next webinar is scheduled for Thursday, May 11th at noon, where our very own Sarah Hahn, our Director of the Stormwater Management Department, will present on the county's ARPA projects. Registration information will follow shortly. We hope to see you there. That's it. Thanks, everybody. Have a great day.
Thanks, Chris. Thanks, everybody. Bye.